Welcome to Love and Guilt in the Anthropocene, a podcast to help people and organizations embrace the adventure of climate action. We are envisioning a world where sustainability comes naturally. I'm Cassandra Thiel. Let's get going. Today we're going to have another reading from the blog. This one is called Powerful Imperfect Tools. I'm talking about data, not people. Here we go. Fresh out of my undergraduate studies in civil engineering, I eagerly signed up for graduate school in a program that focused on sustainability. The topic sounded important and interesting. I was surrounded by professors and other students who also liked to think deeply about big problems. It was so exciting. And then I had my first course on life cycle assessment. LCA is a tool used to quantify the emissions of a product or process across its life cycle. Are you reading this on a phone? Or listening to it on a phone? Well, raw materials like tungsten and silicon have to be extracted from the earth, shipped to manufacturing plants, and produced into the phone in your hand. All those steps have emissions. When you charge your phone at night, you need electricity, generated likely through the burning of fossil fuels and arriving at your phone through a wired infrastructure. That all has emissions. And when your screen cracks or the phone is just too hard to use, you'll throw it away. That has emissions too. These can all be quantified using LCA. Modeling versus measuring. In my undergraduate structures courses, we practiced designing buildings and their foundations. When the length of a column was off by even an inch, there was a problem. When conducting an LCA, I found myself making wild-ass guesses constantly. What kind of material is this? I guess it's a type of plastic. But which type? I guess I'll just put something in and see what happens. When the numbers for the first LCA project finally emerged from my software, I was asked if they felt right. How would I know? The whole thing was so inexact, so painful. Unlike structural engineering, where you determine the size a beam or column needs to be to take a certain amount of force or load, LCA is not a calculation. LCA does not measure actual emissions. LCA is a model to give us an estimate of emissions. We look at our system as a whole, measure what elements we can, often called the system's foreground data, and map those system components, also called unit processes, to databases, telling us the average emissions for the amount of material we're looking at. This is called background data. So for a phone, I would have to know what it was made out of and how much of each material there was. I might also need to know how far it's traveled, how much energy it consumes when charging at night, and what the electricity source is. That's my foreground data. The unit processes are the materials, tungsten, silicon, electricity, etc., and the database I map it to contains all the emissions or background data. It took years of practice and a couple more published LCAs for me to start being comfortable with LCA's relatively inexact results. Not exact, but still powerful. LCA has long been used by various industries, starting in 1969. Though it is an estimate, LCA provides designers, policymakers, and purchasers with valuable quantitative environmental data. The first uses were to determine what types of packaging would be best for bottled beverages, allowing a certain red-colored soda company to make country-level product packaging policies. Product redesign can occur with these results as well, helping companies reduce their use of emissions-intensive materials or replace poorly performing equipment. LCA is also our most effective tool against companies' greenwashing of products. With LCA, sustainability claims on a product can be supported, proving quantitatively that the product actually does perform better than some benchmark. The use of LCA is growing exponentially, and researchers are still working to improve its ease of use and accuracy. I've been using LCA to identify hotspots in medical practice. Are you a surgeon and wondering how to green your practice? I've done enough LCAs now to say that if you're in the US, the majority of your greenhouse gas emissions are coming from your single-use supplies and how they're manufactured. Are you on a hospital procurement team and trying to set up some greener policies? Most LCAs say that reusable medical devices and supplies produce fewer emissions over their lifetime than the equivalent single-use disposable devices. Even reprocessed single-use devices are better than just single-use. Are you concerned about how much energy your department is using? Unless you're in radiology, you could likely work on your heating, ventilation, and air conditioning system if you haven't already upgraded your lighting from incandescents. Realistically, everyone should be trying to source electricity from renewables. When is there enough data? After nearly a decade of working in healthcare, I've learned that medicine, like civil engineering, has its own subspecialties, where each group has their own personalities and their own sense of being special. I often have surgeons approach me from some new to me specialty area saying, "We like what you did in gynecology, orthopedics, radiology, etc., and we want to do our own LCA." First, these surgeons typically don't realize how much time and effort goes into doing an LCA. LCAs require a lot of data, and there's a surprising amount of nuance needed to interpret the results. It is truly work. Second, unless these surgeons are doing something crazy different from other surgeons, I can probably tell what their emissions look like without doing an LCA, because they look like every other surgery. LCA doesn't care if the surgical stainless steel used in a surgery is a DeBakey forceps or a Glover Dux clamp, or even the metal basin all the forceps and clamps get tossed into after use. It's all stainless steel, and all manufactured in roughly the same way. It may be sacrilege to say this to a surgeon, but I don't care what your devices and supplies are, only what they're made out of. I do care, however, about whether those devices and supplies are reusable, how they're made, and how they're disposed of. I also know that having some data tailored to a certain specialty can help motivate those folks, especially, to seek change. In conclusion, though there aren't a lot of LCAs in the healthcare space, I believe there are enough to give us good direction for action. If you think the data are necessary to get your specialty moving, then do it. Capacity building. If you or someone you love is interested in LCA in healthcare, I teach an LCA bootcamp for the healthcare sector, online through Columbia University. Enrollment is now open for the fall session. We enroll teams of 1 to 5 people who have an LCA project in mind, and we coach you through how to do the LCA with actual software. The course is structured with 2 days of intensive instruction. I refer to this as a fire hose of information, followed by 6 weeks of project time and a concluding 2 days of intensive instruction. So far, the feedback from students has been very positive, even those who concluded they do not want to do LCA work themselves. And that's okay. We know that as LCAs become more prevalent, we need both practitioners to conduct solid, well-designed studies and people who can effectively interpret the LCA results and translate it into meaningful action and policy. Data doesn't mean much if no one does anything with it. LCA is a powerful tool, and I'm so glad I've become comfortable with it. It has its limitations, but right now it's one of the best approaches we have for better understanding the sources of various environmental emissions in a system, and it's not going away anytime soon. Thank you for listening. If you want to embrace the adventure of climate action, subscribe to our podcast and check out our Love and Guilt in the Anthropocene blog at clinicallysustainable.substack.com.